So my name is Stephen Mushmack. I'm a senior software engineer. I work for Formidable Labs. Today I'm going to be talking about a very tiny little piece of web optimization images. Specifically, what we call responsive images. So the goal that we're trying to achieve is to serve the appropriately sized images to our users. So if they're on a fast connection with a really big monitor, we want to serve them like big and high quality images. If they're on a slow connection on mobile, we don't want to do that. So we want to give them the best possible image without being wasteful. So according to Google, 60% of bandwidth of an average web page is images alone. So there's a really high ROI if you can make this better. So before we get into like responsive images, just like a little side note here, a pixel is not a pixel anymore. So we have, for example, a monitor that is 1280 pixels wide versus this tiny phone that is almost the same. So how is that? The reason is there's like a difference between a hardware pixel and a software pixel now. So hardware pixel is like the actual unit of light on a monitor. Software pixel is sort of just like a unit of measure, and they aim to be roughly equivalent across devices. So if I look at this web page on a phone versus on a desktop monitor, they're going to be roughly the same size. So device pixel ratio is how we like measure this. And so it's essentially the number of hardware pixels in the software pixel. So like the classic DPI is 1, like up until essentially Apple came out with their Retina a few years ago. That's what you would see. So now you see 2 DPI, 3 DPI, where you've got like 9 hardware pixels for 1 software pixel. And the reason for that is sharper text, sharper images, higher resolution. Side note, Retina doesn't mean anything anymore. When it came out, it was 2 DPI, but now it's all over the place. So what are responsive images? So first, they are the optimal size for the resolution and device pixel ratio. So they're not too small, or else they'll be pixelated, not too big, or else they'll be wasting bandwidth. So they adhere to the design, so they have to fit where the design wanted to be on the page. It can be full width, it can be 25% width, whatever the design is. They have to be cacheable, both in the browser and at the edge in CDNs. And they have to respect server-side rendering. So it can't be something that the client side figures out, because if a browser is running without JavaScript, the server sends out some HTML. It needs to be the same image that whatever client side would work. So that gets rid of like using JavaScript to figure out what the resolution is, what my container width is. No JavaScript. Chris. So browsers are already optimized to do this. So what does the browser already know? Without the developer telling me anything, it knows the viewport size, it knows the DPI, the connection speed, the currently cached images. So all we really need to do is tell it 2 things. Here's the list of all the images and their sizes, and here's the size of like the slot that I expect this image to go in. So with those 2 pieces of information, it can make an intelligent decision. So how do we do it? So who has heard of these 2 attributes on an image? Source set and sizes. Yeah. They're not even that new, but no one uses them. I don't know why. So source set, which we'll get into in a second, is where you list all the available images and their sizes. And when I say all available images, I mean versions of the same image. So a picture of a dog in a bunch of different sizes. Sizes is going to be where you tell it about the slots. So, hey, this picture is going to be only 100 pixels wide, or it's going to be full width. And then source is for Internet Explorer, because it doesn't understand either one of those. If you don't care about Explorer, you can leave it off. So here's an example of source set. So it's a comma-separated list of image URLs and then their width. That W there is the software pixel width. So 375 pixels all the way up to 2400 pixels. And just pretend that those are all the same image in different sizes. By the way, that dummyimage.com will give you like a placeholder image at whatever size you put it at. It's pretty cool. So, sizes. This is where you list a media query and then the size of the slot. So, in this case here, we're saying if the device is a minimum of 800 pixels, this image needs to fit in 25% of the viewport width. However, if I'm between 400 and 800 pixels, it's going to be half the viewport width. Otherwise, it's going to be full width. So, we'll look at like an example design here. This is like pretty common. You'll see on desktop we're going to have 4 images across. On tablet, 2 and 2 and 2 and 2, and then on mobile just 1 across. Right? So I'm going to use this layout example. I'm over time? You're over time. I'm almost done. So we'll use this example. No images cached, and the device is at 2 dpi. Alright, so first shot, we just use SRC. The image downloader is always 1600 pixels. It doesn't use the device width or the image slot width. If we add source set, now the browser doesn't know about the image slot because we didn't tell it yet, but it does know about the device width. So you can see here, the math is essentially the device width times the DPI. So we get, for mobile, say 750, and it's going to round up to the next one. It's never going to round down for quality reasons. And notice on the desktop, we actually got a bigger one than we did before. So it's not always good. In this case, it ended up being worse. What you really want to do is you want to do them both together. So then we say, we're going to use the image slot now based on the media query. So let's look at desktop now. Even though we got a really wide desktop, it's only going to be 25% of the width. So it's going to use that 475 number, 2 dpi, and now we know the image needs to be 950, so it's going to round up to the next one at 1080. So there are some services you can use to like generate all these things. You upload one really big image and it does all your sizes for you. Scene7, if you want to pay an exorbitant amount of money. Cloudinary, Akamai, also if you want to spend a lot of money. And you use it like this, you give it like a name, and then each one has its own query parameters.